Hello everyone. Today I'm looking at merge sorted array. You're given two integer arrays, nums1 and nums2, and they're sorted in non-decreasing order, and two integers, m and n, and they represent the number of elements in each array. So we are not returning anything. We are simply inserting these elements into this element, into this array. We're simply inserting these elements into this array, and we're maintaining the size, so 6. So we simply insert these elements. And we have some zeros as placeholders. Okay. So we have nums1 and we have nums2, and so we're going to look at this number, and we're going to look at these numbers separately, so we're going to need separate counters. So let I equal 0, let j equal 0. So counter for nums1, counter for nums2. So while j is less than the length of nums2, because this is the counter for nums2, then we're going to, that's going to make sure we process all the elements. So we're going to look at every element in this. 0, 1, 2. 2 is the last index, and n is 3, so this will look at each index. And we'll, so we're going to check if we can insert the number at this position. So we can ask, is 2 less than or equal to 1? If it's not, then we're going to move our pointer here, and then it is, and so we move 2 here. We move the pointer here for 5. Is 2 is not less than 5, 2 is not less than 5, 3 is not less than 5, and then we get to a 0. And so at that point we're going to need an additional condition, and basically we have m, which is the number of valid elements, so it's 3, but once we add a valid element, we increment j. So m plus j is our valid elements. So let's just go ahead and write some more stuff. So we're going to look at this, and then we're going to compare it to this. So a comparison is used with the if. And so if nums2 at index j, if it's greater than or equal to nums1 at the index of I, then we can insert it and increment our counter for j. And so to insert things, we say the name of the array we're inserting it into. We call the method splice, which will add elements, insert elements into our array. And it takes an input index, it takes a delete counter, and it takes items or elements. So we're deleting nothing. We're inserting at the position I, where the counter is, where the pointer for nums1 is, and we are inserting the number at the index j in our array that we're adding stuff to. So but if we get past all the valid elements, we want to insert the rest of the elements. So we're going to say that if I ever gets to be greater than m plus j, so m is the number of valid elements, and as we add valid elements from nums2 into nums1, this will grow dynamically because j is the counter for which element in nums2 that we've processed. But once we process them and add them, so is 2 less than or equal to 2? Yes, it is. You can go ahead and insert it at that index. We move to 5. And you see 5 is never 5 is greater than or equal, let's see, nums2 of j is greater than or equal to nums1. Well, I mean less than or equal to. Less than or equal to. Oh shit. So if it's less than or equal to, so we compare these. Is 2 less than 1? No, it's not. Is 2 less than or equal to 2? It is, so we insert it here. Is 5 less than or equal to, because you see how we're trying to keep it in order, so we're working from left to right, so we need to make sure we're doing it less than or equal to. But once we get past the number of valid elements, we want to insert everything we got left. And all the while, we're going to be needing to move the I counter, the pointer for nums1, once we find an element. And so that's really it. We need to pop off the elements to maintain the size. So nums1.pop. Okay. Good night, everyone.